The machine that filled your ketchup bottle, that welded your car, that packaged your food, is almost certainly run by software written before you were born. Not old the way your phone gets old like 1968. And here's the strange part. It was designed to look like 1950s wiring, on purpose. This is the most important software you've never seen, and the reason nobody dares replace it. Your instinct says old software means neglect. Somebody who should have upgraded didn't. But this isn't that kind of computer. The machines that build the physical world run on something called a programmable logic controller, a PLC, a small sealed box, no screen, bolted inside a steel cabinet. Your phone is built to be replaced every 2 years. A PLC is built to do the exact same thing 10 million times for 30 years, and never once reboot. Different machine, different rules. To see why, go back to 1968, a General Motors transmission plant. Back then, a machine's logic wasn't code. It was a wall. Hundreds of electromechanical relays wired together by hand. To change the product, an electrician had to physically rewire the wall. It was unreliable, and worse, it was unreadable. Pull out a relay, and often nobody alive could tell you what it had been doing. The logic of the whole factory lived in a tangle of copper that no single person understood. General Motors put out a request: replace the wall with something electronic. The answer came from a small firm in Bedford, Massachusetts, and an engineer named Dick Morley, who sketched it out on New Year's Day, 1968. They called it the 084, not for anything grand, it was simply their 84th project. Inside, it did one thing forever: read every input, solve the logic once, set the outputs, and repeat thousands of times a second. A clockwork loop that never stops. The first one shipped to GM in 1969. The PLC was born. But a rugged computer created a brand new problem. The people who kept these machines alive weren't programmers. They were plant electricians, men who read relay diagrams, not code, and never would. Hand them a language full of curly braces and semicolons, and they'd walk. So Morley's team made a choice that looks tiny, and turns out to be the entire reason this software refuses to die. They made the code look like the wiring. Instead of text, you draw the program as a picture, 2 vertical rails, like the sides of a ladder, with rungs across them. Each rung reads left to right, exactly like current flowing through relays. A switch is a little gap in the line, a contact. The thing it switches on sits at the far end, a coil. An electrician who had never touched a computer could look at this and just read it. They called it ladder logic. The programming language disguised as the very thing it replaced. That single decision is why the software is immortal. The code is readable by the person holding the wrench at 3 in the morning. No priesthood of programmers standing between a factory and its own machines. It got so entrenched that in 1993 it became a global standard with a name only an engineer could love. A 1960s notation imitating 1950s wiring, written into international law, still taught, still shipping, today. And the hardware keeps the same promise. Siemens launched a controller it called the S5 in 1979. It kept selling spare parts for it until September 2020, 41 years. In that final year, those same controllers were still running one of the largest food factories in Europe, filling cans day and night. A computer from the 1970s still on the job during the pandemic, on a factory floor that isn't ancient, that's just trustworthy. Which raises the obvious question, if it's really that old, why not just modernize it, rip it out, put in something new on principle? Because the instant you reach for that button, you meet the real reason nothing ever gets replaced. And it isn't sentiment, it's a number. When a factory line stops without warning, a meter starts running. By Siemens' own estimate, 1 hour of unplanned downtime on an automotive line costs $2.3 million. Work that out. That is more than $600 every second. Across the 500 biggest companies on Earth, unplanned downtime burns about $1.4 trillion a year, roughly 11% of their revenue, near the entire economic output of Spain. That is the invoice for touching a line that already works. So the oldest rule on the factory floor is also the smartest. If it runs, don't touch it. And the companies that broke it became legends, the cautionary kind. In 1999, Hershey rushed a shiny new system live right before Halloween. The candy was sitting in the warehouse. The software simply couldn't get it out the door. More than $100 million of orders stuck. Quarterly profit fell by a fifth. Nike lost over $100 million to a single supply chain glitch. Leaving the 40-year-old code alone isn't laziness, it's arithmetic. But there is one cost that never shows up on the spreadsheet. The whole design bet was that a human could always read the ladder and fix it. The trouble is, those humans are retiring. Nearly 1 in 4 American manufacturing workers is already 55 or older, and of the millions the industry needs this decade, about half those jobs may simply go unfilled. The logic they leave behind is often undocumented, living in someone's memory, not on paper. The code was built to outlive its authors, and it's starting to. So step back. That 40-year-old software isn't a mistake somebody forgot to fix. It is doing precisely what it was designed to do in 1968. Run forever, stay fixable by a human, and never ever surprise you. Everything you'd call a flaw, that it's old, that it's simple, that no one has touched it in decades, is the feature. It was built to be boring. And on a factory floor, boring is priceless. The next time someone calls old technology behind, picture the ladder. The most modern thing about a factory isn't its robots or its dashboards. It's how deliberately, stubbornly old its bones are. A language drawn to look like wiring so that a person could always understand the machine and fix it. Which leaves one quiet question. When the last electrician who can read it finally retires, who picks up the wrench? Thanks for watching The Industrial Stack. If this made you see the world a little differently, hit like and subscribe. The next one is already on your screen.